Students, in this video I am trying to explain to you what is spin-spin splitting in NMR spectroscopy. Now when you look at an NMR spectra, as we have already discussed earlier, it consists of peaks at different delta scale, 0, 1, 2, 3, 4 according to the different chemical environment. Now these peaks that are present in the NMR spectra appears as sometimes as singlet, sometimes it appears as doublet, sometimes it appears as triplet, sometimes as quartet, pentet, and so on. Okay, and it goes on like this, so and so on. So sometimes you can get a sextet, heptet, and so on. Now why do we get this splitting of the peaks? Ideally it should have come as a single peak, which signifies the chemical shift value as well as the type of where the particular proton is coming, but we get this additional information of spin-spin splitting. That means the peaks are splitted into sometimes doublet, sometimes triplet, sometimes quartet. So why are these why are these peaks which are splitting? We will see in this lecture. Now let us look at the one example here where you have CH3, CH2, Br. In this example, we know that this compound will give us two signals. Why they will give us two signals? Because there are two different type of chemically non-equivalent protons here, where if I say this as A and these are B. And we also know that this will come in upfield and this will come in downfield in comparison to each other. Okay, so in the NMR spectroscopy here, in the NMR spectra, the peaks that are going to appear are somewhere like this is the spectra here. Then this CH3 protons should come somewhere here. I'm not drawing it to scale, and this should come in downfield somewhere here. Okay, these are the two different type of peaks that you should get. But what, as I'm saying, so this is here in the upfield region, and this is in the this is in the downfield region, and this is in the upfield region. But as I'm saying that, as I said earlier, these peaks do not appear as just singlets. They appear in, or just one peak, they appear in different types of peaks. So here if I write for this CH3 protons, or this is methyl group, the protons will appear as triplets and they will appear as quartet. They will appear as quartet. Now how can we predict how this triplet and how this quartet is coming is governed by the n+1 rule, where n is the number of hydrogen atoms present in the neighboring carbon atom. So if we see here for the H, these methyl protons, CH3 here, these methyl protons, the neighboring carbon is this one for this, so n is equal to 2 here. So with the n+1 rule we get 2 plus 1, so it's equal to 3. That means we get 3 peaks, or the single peak is now split into 3 peaks and it's called a triplet. So that means now this is coming as these 3 peaks as triplets. Okay, so if we see further here, then let's see for this we have N is equal to, so now N for this one will be the adjacent carbon atom. That means this carbon atom. This carbon atom has how many hydrogens? It has 3 hydrogens. So N plus 1 will be equal to 3 plus 1, which is equal to 4. That means it will be a quartet, which appears here in the spectrum. That means it is coming as 4 peaks. So while looking at the structure, you have to see the adjacent carbon atom, the number of hydrogens present at that carbon atom, and by that way we can predict the type of peaks. So let's see some examples. So if you see this example here, C, C, H, then you have chlorine, chlorine, then you have chlorine, hydrogen, hydrogen. So here we now know that, we know that this hydrogen and this hydrogen, they are chemically equivalent. So we can name it as HA and HA, and then this hydrogen, they are different, so we can name it as HB. So for HB, if we have to take the n plus 1 rule, so according to n plus 1 rule, the number of hydrogen atom in the adjacent carbon atom. So for this hydrogen, the adjacent carbon atom is this one, and the number of hydrogen atom is 1, 2 on this adjacent carbon atom. So it becomes 2 plus 1, which is equal to 3. So we'll get a triplet. That means for this hydrogen we get a triplet. And if we have to take for HA, then for HA n plus 1 rule, so HA, the adjacent carbon atom is this, that this is the carbon atom which the hydrogen is attached, and this is the adjacent carbon atom, and the number of hydrogen atom present in the adjacent carbon atom, that means only one hydrogen is there. So you have 1 plus 1, which is equal to 2. So now it is a doublet. So we get a triplet, and we get a doublet. So just by looking at the structure, you have to first find out what are the different chemically equivalent protons, and then you can use the n plus 1 rule to find out how they split the peaks. Let's take some more example. So looking at this example, we first see how many type of protons are there. So here again, if I will make out this methyl and this methyl protons, they are chemically equivalent, and this is another type of proton. So this we can make it as HA, and this is as HB. Okay, so for HA protons, n plus 1 rule equal to, so HA, there is only one this carbon atom becomes the adjacent carbon atom for these and these, and these are same chemically equivalent. So this is 1 plus 1, which is equal to 2. That means it's a doublet. Okay, and then for HB proton, n plus 1. So now this is critical here. So now here n is equal to 6 plus 1. So now it becomes 7. That is, it is a septet. 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So it's normal. Sometimes it is called as, not sometimes, mostly it is called as multiplets. Okay, so it gets a 7 peak. So here the main thing that you should be careful about is this number 6. You should not put it as 3 plus 1. This is very wrong. It is 6 because this and these methyl protons, they are same, they are equivalent, chemically equivalent. So that's why it is 6. So and 6 plus 1 is 7. So we get a septet. So try to find out the splitting pattern for the following compounds, and also try to predict the that which peak will appear in upfield or downfield. So these are some of the examples that are there. So try it out, and if you have any doubts, kindly ask me, or you can comment in your Google Classroom, and we can discuss. So please go through it.